All right, hello everyone in Chemistry Club. Today I have a very short presentation for us. Um, have you ever wondered what is the true concept of charge? No, when you hear statements like this is positively charged, this is negatively charged, stuff like this is attracted to the North Pole, this is attracted to the South Pole, because if you look at these two statements, they have interrelations. It's just an interaction. Both magnetization and electrostatic attraction or repulsion are actually interactions. But today I want us to talk about something in our program, Chemistry Demystified. All right, what I want us to talk about today is the best explanation for the concept of charge. Now, the topic actually is electrostatic force, and I don't want to go into the topic. We know we've learned about electrostatic force, although I'll still talk about it. We still do some little chemistry that is involved in electrostatic force, or should I rather say chemiphysics that is involved in. Sorry, I am using some informal terms. Just bear with me. All right, let's hit the game. Now today, what's the best way to explain the concept of charge? All right, have you ever asked yourself that question? If you had to explain charge, what does it mean? How do we know that something is positively charged? And how do we separate in space or in chemistry or in science, so to speak? How do we separate between positive charge interaction and negative charge interaction? Now, oftentimes in secondary school, we are taught about charges, and we were told electrons are negatively charged. What actually prove that electrons are negatively charged? The first set of scientists to talk about charge, what was in their mind? I have come to ask myself that question, and I want to it's my pleasure to put it forward today as the topic of our chemistry demystified. Now, I want you to pause the video and give me your own concept of what charge is all about. Some people say that charge is a positive charge is what attracts a negative charge. How do you know a negative charge? We know that both of them attract, but how it's just like saying a guy and a girl. And how you know a guy and a girl is that a guy walks to a girl. No, you know them by their biological makeup. How can we know a positive charge, or what hypothesis or what theorem can we propose that can give us a best explanation for a positive charge and for a negative charge? All right, now I've thought about so many ideas regarding this. And another video coming up is what is the true concept of pi, um, that we oftentimes use in mathematics, in chemistry, in physics. And in mathematics, we were taught that area of a circle is pi r square. What actually is the true concept of pi, and what is the efficacy of pi in chemistry? I know it sounds like, wow, what's pi doing in chemistry? But that's by the way. And today, I've thought about this and I came up with certain um, ideas, not really my ideas though, as to what exactly or the best way to exactly explain the word charge, the best way to exactly explain to me the word charge. And that best way, I got this idea from one of the greatest scientists of all time in one of his equations. And the scientist is I know you must know him, James Clerk Maxwell. James Clerk Maxwell. I know if you're a good physics student, you must have heard of James Clerk Maxwell equation, electromagnetism, and the electromagnetic field. He was one of the people that pioneered a great deal of that equation, and also Gauss, that they have some similarities in their equations. I'm not here to talk about the equation, and sincerely speaking, I don't really understand that equation as much as I had wanted to. I will just tell you the truth, but I got something from that equation that really helped me to understand, or gave me the best explanation for charged particles, something being positively charged and something being negatively charged. Now let's go back to this. If you are conversant with James Clerk Maxwell's equation, you will know, or you will get used to terms that are called source and sink. Source and sink. Let me write it down somewhere. Source and sink. And when I think about these two words, it brings me to a hypothetical conclusion that interaction in space um, is actually governed by these two things, but doubtedly, I believe that it must be more than two. And what makes me believe that it must be more than two is because in the orientation of matter in space, we have three dimension, and we are even exceeding three dimension now. For there to be more than three dimension in the context of interaction of matter in space, it should be more than three options there. Here we have source, we have sink, and for us to have a third dimension means that we're supposed to have another pattern of interaction in space that will have to account for the third dimension. This is my hypothesis though. But let's go back to this. Now, what is source and what is sink? Now, interaction in space, because here we talk about forces. Interaction in space, as Albert Einstein, James Clerk Maxwell, everyone tried to explain in this interaction. We'll come to see from James Clerk Maxwell's equation, one of the most repeated words was like call, was like socks, was like sink. And what does this word actually mean? To have a source and a sink. A good example for this is, imagine you have a sink in your house, and the sink, there is a hole somewhere here, and you know what a sink is, where you used to wash your plate and all the rest of it, and there is a hole somewhere there, and right in that hole they used to cover it. Maybe that you poured a water, this is a source of water, you pour the water and there's water here, then you open the hole from the bottom. There is a kind of tornado like spiral downward drain of the water. Now that downward drain, this is why this is called a sink actually. That downward drain, the effect is something that looks like this. You know, it starts like this and it goes small, and you understand, like a tornado, it sinks down. Now, and there's another type of, if we have something that is called a sink, that means we can possibly have something that is called a source. A source means, now a sink means that this for it to be a sink means that the direction of flow or the direction of interaction goes down. You see, it's moving like a sink, sinking down. Then we can have something that moves up, that spirals up. You have something that is a bit like this when you talk about waves that are diffracting. You know, this in this case, it is this is moving downward. You see, this is moving downward, this is moving upward. For this, I can call this a source. That means there is a point, and from that point something is spiraling out, or something is coming out. But here there is a space, and from that space something is sinking down through a point. If you get this concept very well, it will help. All right, let me try to relate this to the topic we have today. What is actually, to me, I think the best way to explain a positive charge is that a positive charge, and we know that we are taught that positive charge, they divert out, they spread out, and we were taught that negative charge, they come in. So with these two concepts, I can tell you that we can conveniently say that Negative charge is the interaction in space between two charged particles whereby a point acts as a sink. Here you see that it's going inward and this is like a sink, right? So an interaction that behaves like a sink-like interaction, a sink-like, a sink-like interaction, a sink-like interaction, a sink-like interaction, a sink-like interaction is what we can call a negative charge, a sink-like interaction. So, all right, from here, I think the best definition we can give to a negative charge, that concept of something being negatively charged means that is that for that to be a negative charge, it means that that thing creates an interaction in space that acts like a sink, that acts like a sink. So I can say that negative charge or negative, let me put it that way, is like it's a sink-like interaction in space. A sink-like interaction. So it interacts with matters around it, but in such a way that it acts like a point of sink. And then it means that positive charge or positive is a source-like interaction, a source-like interaction in space, a source-like interaction, a source-like a source-like interaction, a source-like interaction in space. All right, now I hope we all are understanding what I'm doing here. If you have a better explanation, you can bring it up, but this is Chemistry Demystified. We try to talk things beyond what we see in textbook, try to hypothesize things using analytical skills. All right, let me try to buttress more on these 2 points. All right, from the concept of like charges attract and unlike charges repel, if you take that concept, let's take this as this is a positive charge, and the positive charge is like acting like a source, right? And this is a source. So the direction of flow is going downward, right? And this is a negative charge. This is a negative charge, and it's acting like a sink. I'm sorry for that. Sorry for that. A source have to let me represent this very well. All right, I'm sorry for that ugly representation. All right, now let's look at this. Um, when we believe that like charges attract, and I think this is the best way to explain it. This interaction is acting like a source, so it's spiraling outwards, and this one is acting like a sink. So what happens is that there is a harmonization. So this is supplying and this is receiving, and when this interaction meets with this interaction, it creates what is called attraction. It creates what is called attraction. But in a situation where, or in a situation where you have two positive charges, this is acting like a source. You see, a source diverges out. Just make sure you understand the representation. A source diverges out from a point, while a sink converges to a point, right? It's just a two representations of um, two different interactions in space. So when two positive charges interact, this is acting like a source, this is acting like a source, and when they meet, um, they they are not compatible. They are not compatible because this is a source, this is a source. They will push towards each other and they will create what is called repulsion. Also, when you have two negative charges, this is acting like a sink, and this is acting um, um, like a sink. At the same time, you will discover that this interaction is not harmonized. This is not supplying, or this is not supplying, or we could say that this supplying, they will hit, jam each other together. It's like it's not a fitting, it's not a best fit, or I don't know how best to the kind of word, the best word to use for this, but you see that this interaction here is not favorable, and because it's not favorable, it creates a repulsion. So an interaction that is not attraction will consequently be a repulsion. But now looking at let me conclude with this. We have a source, and then we have a sink. These two, we have a source and a sink. So this is supplying and this is sinking. So in this kind of situation, you have a very favorable interaction, like I said before, and this interaction creates an attractive force. And this, in conclusion, we can say that like charges repel and unlike charges attract each other. Another phenomenon is also the phenomenon of black hole. I don't know how true it is, but maybe in some other video we'll talk about it. So here, in conclusion, I will represent this with a source and I will represent this with a sink. All right, that's all for today's video. I want to get your comment. Thank you so much for watching.